Okay, so let's get started. Thank you very much for attending this session, and we're going to be talking about some common security vulnerabilities that you wish your Java application didn't have. And we're going to talk about a whole bunch of vulnerabilities. We're going to actually do quite a bit of hacking. We're going to do some live hacking of existing libraries, both in the Java world and the Node world. A vulnerability is a vulnerability, whether it's coming from a Java package or a Node package, so it doesn't really matter that we mix the implementation too much, but the vulnerability is what we're going to be talking about most here. So, a little bit about me to start off with. I run the virtual Jug. I help run the London Jug with Martin and Barry and some others. And I currently work at a company called SNCC, which does some tooling for security dependency checking to make sure that we don't have vulnerabilities in our application. So, one of the big movements that we have seen over the last year or so is something called DevSecOps. Who's heard of DevSecOps here? Yeah, one of the really poorly named decisions that security people have thought, DevOps sounds pretty cool. Let's add sec into the middle of it and see if security can jump on that bandwagon. So what is DevSecOps? Well, DevSecOps is pretty much just that. It's adding security into the traditional DevOps flow. The problems that we have currently around this is that typically deliverables are too feature-oriented. So when we're developing our code, we're caring too much about exactly what it's supposed to do rather than how it does it in terms of security or performance and a whole bunch of other things like that. The life cycle of security delivery has got a lot shorter. As a result, people are trying to deliver every couple of weeks, every week, daily maybe. And one of the things that we need to think about when we're delivering so rapidly is to make sure that we have things like performance or security considerations into our existing flow, into our existing process, so that when we're delivering, we know we're delivering code that is performant, that is secure, as well as sufficiently featureful. So yeah, there's a lack of security focus. From a design point of view, we tend not to think about security. From an architecture point of view, we tend not to think about security. I'll talk a little bit about the differences in security architectures a little bit later as well. But the two key things, is that it's the organization's reputation that's on the line here, and ultimately customer data could be compromised. And there are stories whenever something does break in the industry, the story hits the headlines straight away, and everyone hears about it. So when we talk about how bad the situation is, well, this is quite a shocking stat. 59% of reported vulnerabilities in Maven packages, so Maven Central downloads and so forth, remain unfixed. And a lot of this is potentially largely because a lot of open source packages are perhaps a little bit dormant. They're not as maintained as others. A lot of them perhaps because we don't actually know there's a vulnerability there. Perhaps people aren't necessarily moving to the next level. One of the biggest vulnerabilities that we've seen, of course, is Equifax. Yes?
Sorry, I have a question.
Yes.
Can you say that 59% does it involve old versions or just the latest version?
That's a great question. I would need to check that. I would expect it would be the latest version, but I would need to check that. Yeah, thank you. Equifax was one of the biggest breaches here that we're looking at, and not just because of when we actually look at the post-mortem of it, how bad it actually rolled out, but just because of the number of the number of accounts that have actually been released, particularly in the US. But one of the key things, and this graph doesn't actually have anything to do with Equifax other than it's about struts and Equifax uses struts, is the focus that struts got from attackers once the exploit was public and made available. This is the number of attacks, almost going up to 2,500 attacks on Struts 2 because the exploit was there. One of the things about open source, when people use and reuse open source, if you find an exploit, although it's just one exploit, you have many victims because loads and loads of people actually pull that in. So one of the reasons why attackers target open source and reusable code is because when they do find an exploit, they have many, many victims that they can then attack. But let's not pick on Java. Let's pick on JavaScript because that's a little bit funnier to do. If we look at NPM, NPM is one of the code repositories that has really exploded most. Over 400,000 packages that are indexed in NPM and over 6 billion downloads per month. It just shows the scale, not just of how much people are pushing code to it, but how much people are consuming to it. And as a result of this usage of open source, when we look at our application, what we actually see is the tiny bit of code that you are writing is this little bit in the middle. And you write code which effectively uses this vast array, vast sea of open source code. If we look at a serverless example here, this is just an example that grabs a file and stores it in Amazon's S3, I think. Yeah, Amazon's S3. It's 19 lines of code. But what we're actually seeing from a runtime point of view is 2 direct dependencies, 19 transitive, okay, so dependencies that depend on other packages, which includes a deployment of almost 200,000 lines of code. So the code that we see and write, okay, that's just the start of what we're actually deploying. And when we think about where vulnerabilities and security problems could exist, you've either got this little tiny bit of code here or this huge amount of code which attackers are really going to be targeting. So we're going to go through some numbers through this report that we created last year. And you can see the increase here. Yes, this is NPM, but it's going to be similar for other languages. The increase here, and this is just a single year of downloads per day, 200 million to up to about 400 million almost, in just a year. That's just a year's increase. When we look at the number of indexed packages, increase in total packages indexed over years, this is between October 2016 and 2017, a 60% increase from NPM, almost a 30% increase for Maven. Okay, so we are making available more and more code every single year and consuming that. Quick question for you. What percentage of 430 sites have at least one front-end library with a known security vulnerability? What do you think? 40, did you say? 30, 99? There's always one optimist. 77. So over 3/4 of those 400,000 sites which were looked at have at least one library, front-end library with a vulnerability. If we look, okay, we've talked a bit about Node. Java is winning though. We can see Java is higher, so that's got to be better. The number of critical Java and Node vulnerabilities, Java is increasing, Node is increasing. If you actually look across the ecosystems, they're all increasing. And one of the reasons here is because the number of open source vulnerabilities published every year is massively increasing. Okay, the target here is open source, third-party, reusable code. When we actually look at in terms of how maintainers are reacting, how project open source maintainers are acting, well, it only takes 16 days from, and this is median 16 days, from a maintainer actually realizing a vulnerability exists, being public, to actually going ahead and reacting and patching, from disclosure to fix. Of course, there are potentially loads of other applications that then need to make sure they're running on the correct level, but this is just from a library point of view. When we talk about how long a vulnerability exists in code before it is known, that lasts a little bit longer. So 2.5 years on median average from the time a vulnerability was included in code to actually being known. But we rely on the fact, I'm sure how many developers do we have here? Yeah, pretty much everyone, good old DevOps. So when you grab an open source dependency, I'm sure the first thing you think about is, I wonder how many times this code's been audited, what's their security disclosure policy? Is that right? There is like one nod here. There was a laugh up there and everyone else was scarily silent. 16.8% of open source maintainers consider security know-how to be high. I actually probably think that's probably a little bit high as well. And not even half of just over half of open source maintainers do security audits. Now, I'm sure if we look at something cool and trendy and awesome that everyone's picking up, we wouldn't have anywhere near as many vulnerabilities in some images. What percentage do you think?
77.
Okay, I'll say you're wrong, because I don't like rounding up. But it is equally bad. Yeah, 76.6% of the top 1,000 Docker containers have known vulnerabilities. That's quite scary, huh? So the reasons, I'm going to try and rush through some of these slides if you haven't noticed, because I want to get my hands dirty and start hacking. The reasons why open source vulnerabilities, open source hacking has expanded so much is because open source itself has become more usable over the years. And open source isn't kind of not secure. It's just as secure as most other things, arguably more secure because it has different eyes coming across it, and as vulnerabilities are found, vulnerabilities are fixed, fingers crossed. So we're not saying it's any less secure than kind of proprietary closed source code. But as I mentioned, attackers are targeting it because one vulnerability has many victims. Attackers aren't going to try and find, or they're less likely to try and find bugs in closed source code where there's only one victim. That's kind of not using the best use of your time. So, we've talked about the problem. What's the solution? Three things, and quite similar to people who are trying to do DevOps. Who's doing DevOps these days, or thinks they're doing DevOps? Not too many. Okay, maybe most of you are, but you just don't want to kind of say you're doing DevOps because the term is very much overloaded. But when we try and introduce security into the process, into our current pipeline, current infrastructure, we really need three things to be done. A team culture change. We need to start thinking about security. We need maybe to include security practitioners into our teams, bring them on in a similar way to operations teams. Discuss features with them from design going forward. We also need to improve communication so that when things happen in our environment, we have the right levels of raising awareness and levels of communication so that can be addressed. Process, as always. Who likes changing their processes? Like two weird people. Okay. Generally, people don't like changing their. They like doing their one thing, right? You want to deliver software. Okay. You don't want to add more and more process onto that, so that you're effectively doing more to deliver software. So what we want to do, in fact, I'll talk about that just in a sec. The third thing is tooling. Okay, I'm from a tooling vendor, but I will say that tooling alone will not fix anything. Okay, you need all three of these in my opinion, to even really address this. So team culture. When we talk about team culture, we're looking at all these different roles. Everyone's going to care about different things. Okay, everyone's going to have different goals. One of the biggest thing about creating one team culture, a team culture that has a similar goal. We even talk about what we're trying to achieve, doing it early. That way, we're not throwing code over a wall to operations that have a completely different view of what we're trying to achieve. When we talk about process, we want to integrate what we're doing. We want to integrate security into our existing process so that we can still deliver every week, every day, every 2 weeks. Okay, but we increase the security, reduce the risk of vulnerabilities. And one of the ways we can do that is through tooling. There is a lot of heavy lifting if you're not using tooling. One of the things tooling does is it automates manual steps away, easily reproducible manual steps. That's why we use automation. We want to be alerted throughout our entire life cycle, because remember, a vulnerability life cycle is very, very easy. First of all, it's vulnerable, it's unknown, it's known, and then it's fixed, okay? And that can happen at any stage throughout your pipeline, whether it's before design, during development, during deployment, during your CI. It can happen at any stage, so you need to make sure that we are testing using tooling at all stages from design, or from development really, all the way through to production and beyond, and maintenance. So, what are our considerations when we talk about security? This is a ThoughtWorks kind of mantra: prevention, detection, response, and recovery. Clearly, people really think about prevention, and that's really where we kind of start thinking and stop thinking. Prevention: how can we stop malicious parties gaining access to whether it's data, our services, whatever. Detection is more about how we know when someone's hacked us. Okay, if you look at something like the Struts vulnerability in Equifax, I think they went 1 month or 2 months, no, 1 month I think, after they were breached, before they even realized they were breached. So it's very, very important that we have tools, whether it's Splunk or whatever, whether we're using rsync or something like that, to pull our logs, to review our logs, to try and find where attackers are getting in. The absence of logs is a really good way of understanding that attackers have been there, because they like to kind of delete their traces, their footsteps. Response: how do we respond when something's happened? response is really important because hacks and breaches, a hack is just someone has, got into your system. A breach is when someone takes the data, takes sensitive information. Hacks happen all the time. Breaches happen rarely. How do you stop a hack from becoming a breach? This is what we're thinking about, how once we detect, how we respond. And recovery is a very, very important one because when we are hacked, we want to clear all the footprint of an attacker on our system. Attackers are very good at, for instance, using LS or overwriting LS, overwriting PS to make sure that even when they're on your system, you can't even see the software they've installed. You can't even see their processes that are running. So when you have been attacked, the best thing to do is clear out, absolutely burn your infrastructure to the ground, and then build up from scratch. And backups are very, very important. Having your environment, whether you're using microservices or whether you're using monolith or serverless, it's going to be trickier, the more complex your environment, but doing it from scratch will most eliminate and most reduce the risk of attackers still remaining beyond your recovery. So let's talk about prevention a little bit more because there's and a lot of this actually I've taken from I'm working with Sam Newman on a couple of blogs and a cheat sheet, and we were talking about one of the things in a book by Bruce Schneier around attack trees. And attack trees are really about looking at your system and trying to understand what attackers are trying to get to and understand where the risk is coming. How is an attacker going to get to my data? How is an attacker going to get to my specific services that I care about? So he uses in his book an example where he wants to open a safe. That's the goal of an attacker. And the question is, how do they open that safe? Well, you can pick a lock, you can learn the combination, or you can cut the safe open. Okay, starting to get a little bit A-team-like. How do we learn the combination? Well, we can find it written down, or we can get it from the target. You can get it from the target via blackmail, or we can threaten them, or you can bribe them. If we actually think about where the genuine risk is going to happen, I'm sure everyone has seen the quickest way of doing something like this, which is having a password written on a Post-it note stuck to a monitor or something similar like that. That is the easiest way typically of getting into these kind of systems. So understanding, and you can get third parties to kind of do this for you as a kind of consultancy route, or you can do it yourself, but working out how people are going to try and attack you, working out the risk, and then focusing on that. It's been pretty hot recently in the UK. Okay, I'm sure loads of people have double locked their doors and left their windows open so that the heat can nicely dissipate out. Right? When we're thinking about security, we think about where the high risk chances of someone coming in. If you've got a window open, it's no point double locking your door because people aren't going to come through the door. They're going to simply just climb through the window. So we've only got a couple of slides left. You'll be happy to hear, and then we'll start hacking. Let's talk about application architecture. Who's running on a wonderful monolith, or a crappy monolith? I don't care. Who's running on microservices, and who's taking the dive into serverless? A few people. Cool. Right. So when we think about the application architecture considerations for security, what are we looking at? Well, when we think about a monolith. Security is actually a little bit easier because our monolith is typically running in one process or a small number of processes. Very often they don't actually need to communicate because a lot of the communication is happening in process. You'll have a bigger perimeter or a fewer number of perimeters because it's essentially a larger amount of your computation is happening in one place. And as a result, there is less surface area to attack for an attacker. Okay, you have smaller entities. Well, not smaller entities, but fewer entities that people can attack. And largely, you're going to be running on the same stack. You're very likely in this room, it's going to be a Java stack, some kind of JVM stack, and it's going to be the same across your entire deployment. From a microservices point of view, the communication is going to be happening in the open. Although it's going to be behind your main perimeter, your services are going to be talking to each other. And this, one of the things that we can never say is it's okay if they're just talking via HTTP because they're within my big perimeter. Okay, you've got to assume people are going to get in through one way or another, and when they do, you don't want to be talking HTTP, you want to be talking HTTPS. Okay, because you don't want man-in-the-middle attacks, you don't want people sniffing, understanding what's being passed. These are the kind of things that when an attacker gets in, they'll try and sit there and they'll try and learn about your system. The Struts example, the Equifax example, the attackers were there for about a month learning through the system before they actually made their breach. So, in a microservices example, if people are working through HTTP, trying to provide man-in-the-middle services whereby, packets are being sniffed, communications being sniffed, different messages are being passed to augment the messages and things like that. That's very, very easy unless you're using HTTPS. Your surface area of attack is going to be much larger because you have many, many services. So there's many different services, APIs to attack. Equally, you're a little bit more protected because if you do breach a service, you've only breached that service, that one service. How much can you actually get? In order to actually really kind of breach a wider system, you need to breach a number of microservices, the correct microservices, and as a result, you need to go through more perimeters. If we're looking at serverless, as I mentioned, attackers, they will tend to sit in your environment for weeks, months, learning information, grabbing knowledge, perhaps finding better ways to get in with more authentication. And one of the things about serverless is serverless functions, they'll come and go. So it reduces the risk of an attacker staying in your system, learning, grabbing knowledge about your system, because as soon as the computation's done, it's like your function's going to go away. You also have other things that are taken away from you. For example, everyone loves patching operating systems, right? Yeah, really, really great fun. Obviously, with serverless, yes, there is a server, but it's being taken away from you. People are managing that for you. Same with operating system patches. I've done that slide. So let's just go ahead and hack, shall we? I'm going to show you a bunch of hacks. And as I mentioned, some will be Java hacks, some will be NPM hacks, but the key thing is looking at the vulnerability and how attackers go into the vulnerability. So we'll start with Java. I'm going to show you two hacks to start off with. One is going to, that's quite kind of, oh, you can't see that. You're looking at my email. And you're not telling me. Oh my God. Displays. There we go. I hope there was nothing too incriminating there. Right, so the first hack we're going to do, have I got Eclipse running? I do. Have I got it reasonably? Yes. So let's do Spring, first of all. Who uses Spring here? Who uses Spring Data? Who uses Spring Data REST? Quite a few, significant number of hands. Who's heard of Spring Break? One person. Okay. Spring Break is a remote code execution vulnerability in Spring Data REST. And Spring Data REST allows you to expose your domain objects, the information in your Spring Data domain, and expose it over a REST interface. So what we have here, it's not very easy to see, but let's have a look. In my Spring Goof application that I've created, it's just a Spring, I think I'm using Spring 152, Spring Boot 152. And in here, in my main, I actually have a little initializer, which is going to add some items to my grocery list. And my items here, beans, milk, bread, and also a double, which is just going to be the cost. After that, I'm going to run some queries, so a find all, for example, and things like that. If I go to my repository, my domain, it's just a simple domain object, which is an item. It's obviously an entity, and it has some interesting or not interesting fields. I have my repository. My repository extends the CRUD repository. This piece is Spring Data. It allows me to abstract away a lot of the kind of backend, what backend I'm using, giving me a nice clean interface that I can access most backends with. In here, I have a couple of useful methods, find all, find by name, all those kind of things. But the key piece here is the repository REST resource, which allows me to access a whole bunch of this content via REST, and it will pass me a nice little JSON object that I can see what I'm doing. So we're going to hack this. Is this running? Let me just make sure. No, it's not. I'll get this running. Spring Goof, and I will Maven Spring Boot run. So I'm going to run this locally on my machine, and the exploit is. Where am I? Java Goof. So the exploit. Sorry, I really struggle to type and speak at the same time. Exploits. So here are the exploits. I'm going to cat this JSON. And this JSON is effectively providing the command that I actually need to run. It's going to be effectively getting the runtime, performing an exec, and then passing a command, which I'm going to substitute later. This, I'm actually, if I cat let's do env. If I cat that, you can see what we're actually doing is we're adding it in here after the content type. And we are, at this point, passing in exec of env. So we're going to grab the environment variables, which is going to effectively grab it straight from my machine. So if I was to execute that, there we go. So that's going through. It's calling a RESTful service. The RESTful service in this case is localhost items 1. If I wanted to grab that, you'll actually see what it returns here, or not. Okay, so that's actually the endpoint I'm hitting. And as a result of adding that into the headers, it's using the Spring expression language, and I'm getting my full environment variables. Okay. From here, who carries things like usernames and passwords in their environment variables? A few hands, right? This is where people start gathering information. I can equally do a similar thing, but instead of grabbing my environment variables, I'm just going to do a cat of a file. In this case, it's going to be my password. Okay, my etc. password. So you can start gathering information. Useful files around the system, for example, I might grab, password files aren't actually as useful as they once were, but I might want to grab config information. I might want to look around the file system and work out what are in the config files, maybe try and find other areas which are vulnerable to attack. So that's Spring Break, and it's very, very simple to kind of fix. You just upgrade to a newer version of, I think it's the Spring Data REST Web MVC package, and then you are good. You're patched. So all of this is known. I'm sure there's a bunch of people, maybe even in this room, that are vulnerable to this. The next thing I'm going to show you is actually kind of similar. I'm going to go into my Java goof, and in here I need to Maven Tomcat 7. This is going to be running a very simple application, which is a to-do style application. And in this to-do style application, I can sign up. I can say my name is Simon, my email Simon@snick. That'll do. Interestingly, I thought those two passwords are different, but hey. I can create to-dos here, so present at DevSecOps. We'll say that's the 5th of February 1970. It's pretty high. Create, and there we have it. What we can see there, of course, is that we're using a version of struts which is vulnerable. The websites aren't normally this kind in giving us this information, but this is just a demo app. So what I can do is I can exploit that, knowing that. I'm going to go into my Java goof. I'm going to go into my exploits, and here, if I show you the struts exploit, this is a slightly more complex combination of commands, but what this is essentially doing is causing an error to occur, going down a specific error path in struts, whereby when struts then grabs tries to get information about the error and get information about the exception, it actually invokes our code. And in our code at that point, we can run whatever we want. So in this case, if I was to let's cat the struts exploit.sh, we have this. And what I'm going to be doing is I'm just going to sed the command there for /env, for example, execute that on localhost. As a result, I can grab my environment variables. Okay, and this is just, there's absolutely no setup to this at all. I'm just sending a request to that website. Nothing special about it other than specific content in my headers, and I grab information about the system. And of course, I can do exactly the same if I wanted to get the etc. password and any other files on that system. The next thing I'm going to do, how much time have we got? Plenty. Okay, next thing I want to do is I want to go to localhost 3001. Oh, look, this is from a previous go. Okay, so this is my goof to do application, and this is a goof to do application which is written in Node, and we have simply a text box here. We have an about button here, which maybe, which essentially provides an about HTML, serving it from the public directory. Nothing too much. We can do stuff here. We can say buy milk or mile. We can say buy beer. And it'll put that in bold because we're allowed to use markup. Markup is supported here. We can do a whole bunch of different things, just adding to-dos, removing to-dos, editing to-dos, and so forth. But if I was to... Actually, have I got... Oh, I have. Oh, that's cool. Let's see if I can go here quickly. Yes. Okay, cool. So I'm just going to use Snick just to show some of the vulnerability types. But in here... Snick will look through all my dependencies and it will tell me which vulnerabilities exist in my dependencies. So here we can see the first one I'm actually going to look at is a directory traversal vulnerability. It's a medium severity vulnerability. This is a directory traversal vulnerability in ST, which is a package that allows us to serve content. So who knows what a directory traversal vulnerability is? Okay, a few people. Directory traversal is essentially where an attacker, a malicious attacker, can break out of a directory in which you wish them to be in. So, for example, if you are trying to provide the public content from the public directory, someone is actually able to break out of that directory and look at other things on your file system. So let's try that. If I go back here. If we go to our about, what we want to do here is break out of this directory. How can we? If I was to actually show you from here, if I was to, I've already got it there. Excellent. If I was to curl the about HTML, we get that HTML back, which is just the usual about HTML. How can I break out of that directory? Any ideas? Say again. Encoded? Do we need to do it encoded? Encoded as a way. Typically, the way would be to try a .. slash. Whoops. But if we try .. slash, we obviously the ST module is smart enough to know we shouldn't do .. But you're absolutely right. Encoding. Do you know what the encoding is for a dot? Bam. There we go. You've done this before, huh? I wouldn't have said yeah. Oh, right. Okay, so %2e, and bang, we've actually broken out of that directory, and we have a directory listing. So what can we do then? Well, why not just do that again and again and again and again, and again and again and again, and we're at my, no, are we? Yeah, we're at my root. And the nice thing is, if I do it again and again and again and again, I still get to my root, okay? From there, if I wanted to, I can curl the / etc. password, and now we have my passwords, okay? And this is just curling an about page with directory traversal, going back and breaking out of my existing directory. Any questions so far? And this is all very well and good because this is my own application. So this is fine. If you want to do this, you can go to github/snick/goof. And there you have all the source code to do it yourself. I would very much recommend you give it a good old play there and not do it on a live website somewhere. So let's find something else. Instead of a directory traversal, let's try, let's try this. Cross-site scripting. Everyone knows about cross-site scripting, right? Where we can get scripts, malicious scripts potentially, executing on someone else's machine. So, what's the typical cross-site scripting we would try and do on this website? Anyone? What would you try if you want to try and execute a script? An alert. Like this. Oops. Like this, right? Doesn't work because Marked is actually fairly clever and it appreciates that it does input validation and output validation. So it's understanding that you're trying to run a script. As a result, it stops that script from actually becoming executable. Any other way in Markdown we can provide a script? Maybe if I was to try a URL, so how about this? Well, actually, let's try that first with this. If I was to do that, that works, okay, because it's plain, simple Markdown. But if I was to do that again, but with a bad link, and this bad link is JavaScript alert, then what we're effectively doing, this is a valid JavaScript link, okay? If we try and do that, then we still can't break. We still can't work it out because it's actually there, but the Goof application has this sanitize function, and this sanitize function realizes we're trying to execute a JavaScript link, JavaScript script, and it tries to break that. So anything else we can do to maybe convince the Marked library that we are not running a JavaScript script here? So in here? So in the middle of the word JavaScript, write JavaScript.
Yeah, if somebody's trimming out the word JavaScript and they take it out, it becomes JavaScript again.
That is one of the best suggestions I've heard. Who in this room thinks that's going to work? Wow. Okay, so it looks like it's taken off. That's really interesting. Okay, but yes. But in our href, it has taken off the closing brace, and of course, it hasn't trimmed out JavaScript. But yeah, so it won't actually run as JavaScript because it makes no sense, which is why when you click it, nothing happens. But that's a great shout. I love that. Right, what else can we do then? I'm going to just take this out just temporarily. It didn't like the closing brace. Did you see that? How can we represent the closing brace? Who got the double dot? Do you know the URL encoding for a closing brace? No, it doesn't surprise me. I can barely remember it. It's you'll kick yourself. Ampersand hash 41 there. Okay, that's the closing brace. Also, the colon is 58. Okay, so now we're trying to remove the aspects of which perhaps the sanitize function is grabbing. Who thinks that's going to work? No one, huh? One person. Oh, close. Still there, and it's actually represented it as colons, but it just still doesn't work. And that doesn't work either. Now the reason it doesn't work, what we're actually going to do to make this work is we're actually going to get the browser to display it, even though the Marked interface is showing it as something different. The Marked interface realizes this pattern is a semicolon, a colon, and it's intently not showing it. But if I was to type this here, this is a valid statement here. There's no semicolon after the 58 there, so that's actually not a valid statement. So this is going to pass the Marked sanitization. But the browser is both clever and stupid at the same time. It's clever because it thinks, I can just about see what you're trying to do there. I'm going to show this as a colon because I think that's what you're trying to do. So if I was to run this, all of a sudden then we get our bad link. And if I was to click on that bad link, then we get our alert. And at this point, I can then throw in whatever JavaScript I want into this location and grab people's cookies, throw that to my bad website, and start collecting data about people's cookies and sessions and hijack their session and so forth. So that's an interesting one whereby the package was doing the right thing, but the actual browser allowed us to hack by auto-completing something a little bit poorly. Okay, next thing I'm going to show you, who loves regular expression? Who uses regular expression? Yeah, pretty much everyone. Okay, right. What we're going to do is we're going to show you. Well, regular expression's great because it can match things reasonably quickly, unless the string is absolutely huge. Then it takes a while. It takes a while, particularly if it can't match, because it uses this backtracking algorithm. Let me give you an example. Okay, in here, if I was to which one do I want? MS3. Yes, MS3. Let me just check. The MS library. Yes, here we go. So the MS module has a regular expression denial of service. This is where a denial of service occurs because a regular expression computation is just taking so long it's holding up that thread. So let's show this. If I was to just type MS1, for example, here we have an example where what we're going to do is we're going to call mum. We're going to call the non-American mum in 20 minutes. That took a little bit of time, not too long. Took a reasonable amount of time. If I come back here, and if I come back here, and I refresh that, then we have call mum 20 minutes. And what it's done is it's used regular expressions to match the time where I said in 20 minutes. It worked out that was a time, and it added it as this 20 minutes in brackets. So if I want to do something a little bit nastier on that, so let's type MS2. What we're going to do this time is we're going to buy milk in 60,000 fives minutes. Okay, so there is a huge number of fives we're sending it plus minutes. If I was to execute that, it doesn't take that long. It's fairly quick, and the reason it's quick is because it can match, and it can match straight away. Now, if I was to come back here, you'll see buy milk in infinity days. Wonderful. Now, if I was to do something a little bit tricky, in fact, let me just talk about regular expressions very quickly. A regular expression. If I was to do a regular expression like A plus star, something like A plus and then in brackets with a star, if I was to give it 5 A's here, that could actually match in a number of different ways. It could do, perhaps the A plus could actually itself match 5 A's, or it could perhaps match 1 A with the A plus 5 times with the star. Okay, there are a different number of ways it can actually match. And if it can't find a match, it'll actually use a backtracking algorithm to work as hard as it can to exhaust all possibilities before it would say, okay, I fail. So what if instead of these 60,000 fives, when we say minutes, oh dear. Hopefully this will work. Let's try that again quick. Yep. Instead of these 60,000 fives followed by minutes, at the end of minutes, I'm just going to change the S to an A. And it's going to try its utmost to match that. And every single time it gets to the minute, it goes to the it can't match minutes, so it goes back and tries all other routes. If I was to now try that, we hang. If I was to come back here, okay, I've got a denial of service. In this case, it's going to come back any second now. But if I was to add another 0 on that and do 600,000, it would be the rest of the day that would be going. If I did this multiple times, just basically took over all your threads, took over all your services, you then have a complete denial of service on your website. Or you could be one of those fortunate people using serverless, in which case you'll just get a massive bill at the end because I'm just constantly using all your functions. This is a regular expression denial of service. We have, I believe, 5 minutes left. Do I have time to show you another one? Let me show you one really, really quickly. This is actually a node-specific one. Everyone's heard of Heartbleed, right, where you get some memory and it's actually not being cleared when it gets to you and things like that. There's this thing in Node, which is a buffer, or as if I pass it a string, it'll give me 3 pieces of information back. And this is actually a vulnerability which you won't see here, because I'm actually using a version of Node above version 4. But you'll get the idea. If I remove if I turn that into an integer rather than a string, what I'm actually going to do is get provided with 100 spaces of memory. Now, in Node 4, I think it's actually fixed beyond Node 4. In Node 4, this would actually give me a whole bunch of information in these memory slots. And at this point, if I were to, this is actually the Mongoose issue. If I were to, I think it's, I need to break out of that quick. Type mon3. Oh damn. Here we go. So in this case, if we were to do this and actually make an invocation whereby instead of providing content, what we're actually doing is providing a string in this case, but I think I can pass this as just a number of 800. Maybe not. What this is going to do is it's going to provide me okay, I'm surprised that's, oh I see. What am I missing here? Oh, did I not Control C that one? That's weird. I'm just piping that to an HTTP. Do I need an extra quote? Where? So I'm echoing there and there. There we go. Okay, so I'm passing in that content with 400. Let's type with 800. If I type mon4 again, yeah, okay, let's just vi that. I have no idea why that didn't work. Oh, right. Just believe me, that would be terrible. But no, unfortunately, because this is Node 8, I think I'm running on right now, you'd actually just see a whole bunch of items here, which would be blank. But in Node 4, you would actually get a whole bunch of binary across there, and you will see a whole bunch of stuff which was in memory, and this can include source code and a whole bunch of other things. So what an attacker would typically do, they would create these to-dos, they would find little bits of information about your source, about your application, running application, and then they would delete these straight after, so they would remove the trace, and they'd gradually just be taking snapshots of what's in your current memory, or what was in your previous memory. So that was some fun, almost all working live hacking. That's everything I had with 1 minute to go. So, any questions? No questions. Okay, well, thank you very much. Appreciate you coming. Thank you.